I want to talk about planetary models. Planetary models, we're going to start with the geocentric. Geo prefix means Earth. Earth is in the center. So everything is revolving around the Earth. The sun, the moon, the planets, everything. Here's the only problem with that one. Standing here on the Earth and looking at the planets, they can't explain why the planets seem to slow down or go into retrograde. Makes no sense. So the whole idea is the 1500s you had your enlightenment. All of a sudden science takes on. Technology, the telescope. What they discover is that the Earth is not the center. The sun is the center of our solar system, and the planets revolve around it. Helio prefix means sun, sun-centered. All right, so this one, as the planets get closer to the sun, there's a greater gravitational attraction. They speed up. As the planets move further away from the sun in its orbit, it slows down because there's less attraction. So with this one, it actually explained why certain planets sped up at certain times and then slowed down at others. Now, all the planets don't have perfect circle orbits. Some of them are more oval. So the more extreme their orbits, the greater the difference in the speed it's going to be. Closer to, greater gravitational attraction, the faster it goes. Further away, the less the attraction, the slower it goes. All right, so we're going to look at your reference table, page 15, at the bottom. Solar system data. What's the difference between the terrestrial and Jovian planets? Terrestrial meaning land, and Jovian are gases. The inner four planets, Mercury, Venus, Earth, Mars, are my terrestrial planets. My outer planets, my four outer planets, Jupiter, Saturn, Uranus, and Neptune, they're Jovian planets. So get your reference table out, page 15 at the bottom. If I have you go to the column where it says equatorial diameter, you'll notice the size, which is your equatorial diameter. The four inner planets, or my terrestrial planets, are much smaller than my four outer planets, or my Jovian planets. The smallest of the planets is Mercury. The largest of the terrestrial planets is the Earth. But then again, if I look at my Jovian planets, my smallest Jovian planet is Neptune. Neptune is a lot larger, about 4 times larger than that of the Earth. So Jovian larger, terrestrial smaller. Composition-wise, if I'm looking at my Jovian planets, they're gaseous. If I look at my terrestrial means land, they're rocky. In between my terrestrial planets and my Jovian planets, or in between Mars and Jupiter, is where my asteroid belt is. All right, the asteroids that are actually orbiting the sun, or orbiting between Mars and Jupiter. All right, since I mentioned asteroid belt, well, what is an asteroid? It's mostly carbon, have some iron and nickel in it, and little silicates. Remember when we did minerals and we looked at quartz and we said quartz was a silicate? Because it had silicon and oxygen in it. They orbit the sun in ellipses, or ovals. Whereas a comet, every once in a while you hear about it, Hale-Bopp comet, Halley's comet, that's made of dust, ammonia, methane, and ice. Now, when the comet gets close enough to the sun, it melts the ice. It releases that gas. That creates the tail of the comet. Next, what's the difference between a meteor, meteorite, and meteoroid? Well, a meteor, meteorite, and meteoroid are all fragments of rocks that are mostly iron and nickel. The three depend on their location. If it's out in space and hasn't gotten to the Earth's atmosphere yet, it's a meteoroid. If it's gone into the Earth's atmosphere and it's burning up, also known as your shooting star, that's a meteor. So your meteor shower that I put in your stream in April, that's because it was burning in the Earth's atmosphere. A meteorite hasn't completely burned up in the Earth's atmosphere. It actually has hit the ground. Some of your meteorites are so small that you wouldn't even realize what they were. Some of it, they're large enough that you actually can see. I'll put a little video up in your stream showing you a meteorite that hit in Russia in 2013. Luckily, it didn't hit land, it actually got into the water.